When that structure becomes abnormal and permissive, that the cancer is allowed to grow. And in fact, in pancreatic cancer that Ron talked about, it's amazing to me. Ron got me involved in pancreatic cancer, so thank you, Ron. Only 10% of the cells in the pancreatic cancer are actually pancreatic cancer cells. Those cells are kind of massaging or manicuring the rest of their microenvironment, the rest of the environment surrounding them, to enable the cancer cells to survive and thrive. So with aging, we have changes in our body, decreases in the effectiveness of the immune system, consistent or persistent inflammatory situations that arise that change the structures that enable cells that are already initiated to progress. I remembered that, Ron.
Ruben, do you want to say something about metabolism here?
Yeah, well, to echo and to follow up on what Ron said, I think we also have
only in the past 5 years or so really learned some of the pathways that exercise hinges on, and also diet hinges on them. So actually by eating a good diet, believe it or not, you by keeping balance in your metabolism, you actually also keep balance in some of these growth control points that effectively keep the cancer in check. And we haven't historically thought about things that way, that exercise or diet could actually be regulating enzymes in all the different cells of our body, but incredibly they are. So that's exciting, and I think ties in nicely with different things that people are working on here. So stay tuned.
Thank you. Jeff, you made the point that there isn't one cancer. There are many cancers. What do the cancers have in common? What do you look for?
So I think that there are two really important parts of that question, Marna. One is, what are the underlying features of cancer? And the second one that's really important for treatment is how do we identify the commonality so that we can use them as a strength for us to develop drugs that are targeted against commonalities that we can use in different cancers. Okay. So what are the commonalities? Well, we've already talked about some of them. Cancers all have to have mutations in genes that control their ability to grow, to survive, to evade drugs, to gain this plasticity that I talked about, to become stem-like, and to move and colonize different sites. Within this, there are enzymes such as the one that Tony discovered and now is the founding member of 530. How many of them are there now, Tony? 35, 52, 550 something?
540, right?
even Tony can remember. Okay. So Tony has an incredible memory. So 540 of these kind of kinases, tyrosine kinases. Knowing that, knowing that there are all these kinases that are related to one another that can drive different cancers, we can start to target them and see whether the drugs used to target one can be effective in another. So let me give another example with Dan. So the enzyme that drives chronic myelogenous leukemia is inhibited by the drug Gleevec. It turns out that that drug was developed for another cancer, for another kind of enzyme. That kind of enzyme is mutated in a cancer of the GI tract. So Gleevec can not only be used for CML, it can be used for a cancer of the GI tract. So by thinking about cancers not as diseases of organs, but as diseases of genes and of enzymes and processes, finding out the processes that are in common can empower us to find drugs that can target many types of cancer that we normally wouldn't have treated in that way. There's another commonality that Sue may want to talk about regarding the immune system.
Yeah, I think that an underlying feature of all tumors is the non-tumor cells that Jeff was just talking about. All tumors are surrounded by cells of our immune system, like macrophages, by stromal cells, fibroblasts. These are all common features, and they get manipulated by the cancer. And so a promise of immunotherapy in particular is that, and strategies that target these non-cancer cells, that there'll be more common principles that underlie their function and the way that they're being manipulated in cancer, that drugs aimed at those cells, but not the cancer cells at all, aiming drugs at the non-cancer cells, may hold promise for treating a larger number of cancers, because those might have more common principles across different cancer types and different types of organs. And I think Diana wants to speak about
this is absolutely the hope for epigenetic therapy as well, because we know that epigenetic processes are almost universally dysregulated in cancer. And so the hope really is that we can find those common nodes, the commonality between cancers, again, independent of origin, and that by hitting those nodes, we could really develop drugs that would be effective in a broad range of cancers.
But I think I want to also say that there are so many differences with different types of cancers as well. And again, thinking about our immune system, one of the biggest differences is going to be each of these different mutations, every tumor and every person's tumor, and even when you think more broadly about within a single patient and their metastatic cancers, each of those tumors have different mutational profiles. Some are in common, but some are different for each of those tumors. And so those are now presenting themselves as distinct features, flags on the tumor cells that our immune system can recognize. So while there is going to be some commonality in the treatments we use for cancer, there are also a lot of strategies being aimed for personalized medicine to stimulate the T cells to attack the actual mutations in your tumor that are causing these flags, looking like non-cells. And so there's going to be uncommon, very personalized approaches as well for different therapies.
Diana, we've talked a lot, and we heard Ruben say that Salk was a very special place, well suited to the cancer research and finding cures. What's unique about Salk? How do you find it a very special place for supporting your cancer research?
Yeah, I mean, absolutely. I think as sort of the most junior person here, I've been kind of welcomed with open arms, and it really is this collaborative, collegial environment that really speaks to team science. I think this was the vision of Jonas Salk, to bring the best and the brightest, kind of the French salon of La Jolla, California, and to really use sort of new ways of thinking about old problems. And still to this day, I think our activities, our departments, our architecture is still there in place to facilitate interactions that would normally not occur in traditional building environments or a department environment. And, you know, for my own example, I am very focused on the molecular mechanisms. I have my head buried in the DNA. But so I don't typically think about the cell or the environment at all. But I think when yeah, absolutely. So when I found that my cells were starting to produce things that are known to attract immune cells, it was easy for me to knock on Ron's door, grab a coffee with Sue, and now my lab has really started to initiate a focus on the cross-section of epigenetics, the immune system, and immune oncology, which has been very exciting for us. And I think, you know, at other places this really would have not been encouraged, but when I joined the Salk, Tony said, you know, we expect you to be doing something different in 5 years. And I see that that's already happening in year 2.5. So,
and Diana's a trained immunologist.
Right, yeah. Coming back to my roots, finally. But yeah, so I believe it. It's not something that was, you know, everything that was told to me, I'm finding true.
The secret sauce.
The secret sauce is,
Wonderful. Ron, Ruben talked about speeding up the process from bench to bedside to bench. And we are a cancer center, but we don't have patients. We're not a medical center. How can Salk do that? What's the process for speeding up that, for getting more involved with clinical trials?
I like the term speed because I like race cars. So does Jeff. And
I don't.
I
like my
But you know, the thing about speed is that it takes power, but highly controlled. So Salk is an environment where ideas really drive powerful discovery. But it's not enough just to have the discovery. You have to be able to move that into a place where you can work with clinical collaborators. But what I found that is the case is that if we make a discovery here at Salk, everyone wants to work with us. They're not going to be made at some of the clinical centers. The best clinical centers have the best capacity to turn these into therapeutics. So they're so happy. You don't have to be big to have a big impact. You have to have a big idea, and that can come and does come from Salk. So that's our trick. And the clinical centers love to work with us, number one. And if the discovery is right, you get the big pharma like Merck. We have 2 separate clinical trials with Merck, one of their immuno-oncology drugs, where our drug, the vitamin D component, unlocks the ability of that immune system to come in. So we can accelerate because we start with our power, but everyone wants to work with us. And if we create those connections correctly, we are the drivers of that entire process, and it's working very well now.
Great. Tony, we saw in the movie about your seminal discovery and many cures that led to. Where are the new opportunities today?
Well, I would say from my perspective, the new opportunities involve developing new tyrosine kinase inhibitors, of course, and a new tyrosine kinase inhibitor was approved by the FDA on Tuesday this week, bringing the number up to 32. So there'll clearly be more progress there. And one of the challenges is that tumors often become resistant to a single-agent tyrosine kinase inhibitor, and so one needs to build second and third generation molecules inhibitors that can act on the altered kinase target. So I think going forward, one of the most important things for us to do is to learn how to use targeted drugs like tyrosine kinase inhibitors in combination with other drugs like epigenetic inhibitors, also particularly, as Sue was saying, with immune checkpoint inhibitor antibodies. So we need to learn how to rev up the immune system, target the tumor cells, and try and eliminate tumors. Another very important area that we are trying to do something on is to improve early detection of cancers. The reason why pancreatic cancer, glioblastomas, and ovarian cancers are so deadly is that they are always diagnosed too late. And a better way of identifying tumors early on, blood tests, perhaps circulating DNA molecules, then I think we would have much better So the other major challenge cancer metastasis, how do we identify cells in the tumor itself where not all cells are the same. Tumor cells are very heterogeneous, and we need to be able to find the cells that are going to go on and wander around the body and establish a new tumor at a new site. And we need to be able to do that in a much more thoughtful and analytical way. So overall, I'm optimistic that we can use all of our new knowledge to develop better diagnostics for early detection and therapies, and ultimately conquer cancer by turning it into a chronic disease, so it's a disease one dies with rather than of. And I'm absolutely convinced that the Salk cancer scientists, with their innovative and team approach, will be making major contributions in all of those areas.
Thank you, Tony. Unfortunately, we're running out of time, and we have lots more questions from you all, but I hope you see that we have lots of answers, too. So, well, I'm going to do that. Thank you. No, keep me on track. As we wrap up, Ruben, you made the point in your presentation that we could be helpful. How would you like us to engage with you to be helpful in conquering cancer?
That's great. I just want to, personally thank everyone for being here today. Salk was the first NCI-designated cancer center in San Diego, and this is actually the first time that we have launched an initiative devoted to cancer research in these years. So this is a big dedication and step forward. This is really just the first event. This is literally the first event of things that will go on for the next year and years. And so we're asking you to partner with us, to work with us, and to come with us on this journey as we set out to conquer cancer. It's time now to write the future. Thank you.
Thank you very much again to our panel. I hope from this just short session you all get a glimpse of why I believe that Salk scientists are going to lead the way to cures in our lifetime.
everybody. Thank you for joining us this evening. At the Salk, we're committed to being the place where cures begin. Our goal has been and will be to enrich human life. And one of the areas where we've had perhaps some of our most successful experiences is in cancer research. Several preeminent drugs in the field of cancer, including Gleevec, can all trace their roots back to the laboratories and investigators here at the Salk Institute. Yet we recognize that while significant progress has been made, humanity still has more to do before this cancer becomes a disease of the past. Not so long ago, people thought that polio would always be a threat to human life, and that devices like the iron lung would be a preeminent fixture in hospitals throughout the world. Jonas Salk, whose name is this institute now bears, refused to accept that and persevered until he brought an end to polio's reign of terror. We're here tonight because we carry on Jonas Salk's spirit and determination. We believe that cancer is not only treatable, but it's beatable. I'm glad you've chosen to join us to launch Conquering Cancer. It's a Salk initiative focused on bringing an end to one of the world's most devastating diseases. Over the next couple hours, we'll hear from some men and women at the forefront of cancer discoveries. These are people that have dedicated their lives to see the end of this disease. We're also incredibly honored to have with us this evening Mr. Joe Biden, the 47th President of the United States of America, and one of cancer. Just checking to see if you're listening. I won't make that one again. Joe Biden, the 47th Vice President of the United States and one of cancer research's most dedicated advocates. I also want to welcome Walter Eckert and Tony Hunter, who are two former directors of the Salk Cancer Center. Finally, I'd be remiss at not acknowledging a few special guests tonight who made this tonight possible. First of all, Reverend Tom Whittington, thank you very much. Bob Abrams and Pfizer for their continued support. Vince Keaton and the 45th Vice President of the United States. And dear friend to the Salk Institute. When we first started planning this event, we were all incredibly excited at the prospect of having you right here. Tonight, as I look out at the full crowd, who believe as we do here at the Salk that cancer can be beaten. I'm so glad to be able to share this event with you. The science of cancer medicine is moving at an unprecedented speed. Each day, new leads for more precise, effective cancer therapies are being discovered. At Salk, perhaps like nowhere else, we're able to make discoveries and translate them from concepts to breakthroughs with speed that cancer millions of people have deserved. The video we'll play next will show you just how these breakthroughs are taking have an effect. Progress is important because virtually everybody in this room, if not the world, is impacted in some way by cancer. Our current board trustee chair is just one example. The following video
evade our ability to fight it. So evasion, in one word, is what I think cancer is spectacular at doing. And its ability to evade the normal rules of tissue function, its ability to evade virtually every drug we've thrown at cancer, and its ability to evade the immune system, which is something that I study and have a lot of interest in trying to understand how we can better engineer our immune system to fight cancer. One of the biggest challenges that we face